Hello everybody, it's Tuesday, it's 3 o'clock, that means it's Tech Tuesday. Today I'm going to be talking about PNM basics. I'm going to be talking about DOCSIS proactive network maintenance and talking about some of the basic concepts related to that and showing a few examples. So I think this is going to be really helpful for those of you that are managing DOCSIS cable plants, and I will be right back. Thanks for joining me for Tech Tuesday. So today is about PNM basics. A few weeks ago I did a series on our Pre-Equalization Analyzer tool, which is our DOCSIS PNM application. And as I was going through that and talking about version 5, which is coming out right now, I thought that this might be a good time to talk about just the basics of PNM, how it works, why it's important, and really why you need it. In fact, that's kind of what I titled this, what is it and why you need it, because it really is very powerful as far as what you can do with PNM, and it can make a big difference in how you maintain your cable plant. It can really reduce the cost of maintenance, it can increase efficiency, it can improve your plant as far as the RF efficiency of your plant, and all of that means happier subscribers. So you'll have fewer unplanned outages, you'll be able to respond to things more quickly. So PNM is really powerful, and that is what we're going to be talking about today. So if you would like to just comment as I'm going through this, feel free to comment on the YouTube channel right there under the comment section, the chat section, I should say. And then if you have any questions, feel free to type those in. I may be able to answer it. If not, I can get an answer later as we go through this. So again, thanks for joining me, and let's go ahead and get started here. So let me make sure we get these slides moving. There we are. So what is it? So what is DOCSIS PNM? Well, what it's not is this kind of this break-fix methodology that cable operators have been doing for so long, and I think you know what I mean, where a lot of times you learn you have a problem by a subscriber calling in, or multiple subscribers depending on where the problem is. So it could be a customer calls in and it's something specific at their home, so they call you, you go out there, you figure what's going on, connect up a meter, look around, and then you fix that, right? So it breaks, you fix it. It's reactive, not proactive. And the same would go for an issue where that's maybe impacting multiple subscribers. Although sometimes the issue is on these things, you don't know you have a problem, the customers are kind of dealing with it, wondering if it's going to get any better, and maybe it's something that's gotten worse over time, so they're kind of dealing with it, and then it gets worse and worse. And if it's multiple customers, you may not know that several subscribers, could be 5, 10, 20, 30, are being impacted by something that's out in the mainline cable plant, and they're not happy, and you may not know about it, or you've got a few calling in here and there from various places, and you think it's an individual problem and not necessarily something that's impacting a lot of people. So PNM will help you resolve a lot of these issues more quickly. You'll see where they are, and you can tell if it's something impacting one person or multiple. So what it does is it analyzes the pre-equalization coefficients that are part of DOCSIS and the CMTS. Most of you, if you don't know what pre-equalization is, I'll explain that here in depth in just a moment. A lot of you may know what that is. Most of you, I would think, have this turned on in your CMTS. You may not realize that, but you probably do, I think. And that will tell you which devices are being impacted. When you take this data, actually pre-equalization doesn't do this, but when you take that pre-EQ data and then you analyze it, you can then tell which devices are being impacted by upstream impairments. You can tell the type of impairment. You can tell whether it's, for example, it's a micro-reflection or group delay. You can tell if it's an open or a short. You can tell the type and severity of the issue and its estimated location. So for a micro-reflection, for example, you can tell the length of the echo cavity, which then gives you really good clues as to where it's located. And I'll explain how that works. So it can also show you an in-home issue. You can get a really good indication, is this just affecting this customer? And then it can tell you which devices are being impacted by a common outside impairment, where several devices are passing through the same upstream and they're having the same issue at that spot. So you can kind of isolate those and then find the problem a lot more quickly. So how do we do that? And how does it work? Well, first off, what is pre-equalization? You really need to know this concept to understand it. And this is something that came out in DOCSIS 1.1, I believe, and then it was improved in DOCSIS 2, and it's been it's been in for all that time. And at first there was some controversy about this, but I think, like I say, I think most everybody has pre-EQ turned on now. And what it is, I've got here a picture of a graphic equalizer that you would use for sound. And this is something that I remember, this was back when I was a teenager, this was something that every teenager wanted to have in their car, and I had one because mostly it looked cool, right? So you had these little sliders you could move up and down, and but also, you could adjust the sound the way you wanted to hear it. You could adjust like parts of the treble and the bass and get just that right sound that you wanted to make it sound really good. But again, most of all, it looks really cool to have all these sliders under your radio. And we had them on regular home stereo, that kind of thing, when people had stereos, right? So that's what it is in the sound world. And the idea, other than looking cool and other than kind of making it sound like you think you want it to sound, is the idea is that you've got this audio signal, and you might want to optimize it for certain conditions. It might be your car, the acoustics in your car, or the acoustics of a room where you're going to change things around. It's going to sound a certain way in one environment and not in another, and you want to adjust that. It could be compensating for some other impairment, such as when we get older and our hearing goes, you may want to boost certain things to be able to hear the music better. So you're compensating for things or trying to improve the signal, so to speak, so that it sounds better. Well, DOCSIS pre-equalization is very similar to that. It compensates for bad signals reaching the CMTS due to upstream impairments. So what's basically happening when you're looking at pre-EQ is when the CMTS sees the signal from each cable modem, it looks at it and it says, this particular signal has got some tilt on it, or there's some ripples or whatever, and it's, there's some kind of impairment that's impacting that signal as it comes from the cable modem to me. So it tells the cable modem to adjust its signal using these equalizers that are within the cable modem. And really what it's doing is it's telling the cable modem to pre-distort the signal in such a way that it's the inverse of what it's receiving. So if the signal is looking really tilted like this, it will tell it, okay, well, send me a signal that looks like this. And then when it gets to the CMTS, because it starts out like this, it passes through the impairment, and it's sending the signal like this, then when it gets to the CMTS, it looks nice and flat. So that's basically what it's doing. So it's really great. This has really got nothing to do with PNM from the standpoint of this was around before PNM. The whole idea is that you can, with one command generally in your CMTS, you can turn on pre-EQ, and it makes an immediate difference because the CMTS is then telling the cable modem, adjust your signal so it looks good to me. And that's what it's doing. Here's an example of that. So here is a cable modem haystack where you've got this really bad roll-off. It said here it was due to a diplex filter at the CMTS. I'd gotten this from a Cable Labs document. So you see what this is looking like to the CMTS, but after you turn on pre-EQ, that's going to adjust that signal. Again, get the slant, it's going to tell it send it this way, and it's going to look much flatter when it gets to the CMTS. And as I say, that can make a huge difference. It can give you an immediate 5 to 10 dB improvement, they say, in your upstream signal just by turning that on. So everybody should be doing that, right? Now, there was some controversy kind of in the beginning because this isn't really fixing anything, right? The impairment is still out there. If you still have this really bad microreflection out in your cable plant and it's causing problems, it's still there. Whatever's causing that microreflection is still there. It's just that the signals passing through it can be compensated by this pre-EQ. So there was some controversy as should we turn this on or not, because it's not really solving the problem, it's masking it. And then how will we find anything? How will we find where the problem is if we don't even know we have a problem? And that is an issue because it could be an issue, I should say, because cable plants get worse over time, and the cable modems can only adjust their signals so much. So you could be looking really nice there, cruising along with these nice flat signals, and then suddenly whatever that is, whatever that impairment is, gets worse, and then the cable modem can't adjust any longer, and then it goes off a cliff, and then suddenly the cable modem is offline. You could have multiple cable modems offline if that's an impairment that's affecting lots of people. But the good news is that DOCSIS PNM allows you to see these things. So it's using the pre-EQ data to allow you to see these things so that you can then target them using pre-EQ. So you turn it on and get a much better, healthier plant for your subscribers from the standpoint of what the signals look like, and then you can use that data to see where the problems are and really get specific on that. So, Before I go any further here, I also wanted to talk about what a digital tap is, because I'm going to be talking about taps, and I don't want anybody to be confused about that if you're new to PNM. So in PNM, there's something called a pre-EQ tap or a digital tap, and that is not what most people think of when they think of a tap in a cable plant, which would be a mainline tap. So you've got that tap that's connecting your drops to various different customers. So they're not the same. Pre-EQ taps are signal processing. They're little slices of the spectrum, whereas obviously a mainline tap is a piece of hardware, passive device that you're going to put out there in your cable plant. So they're not related, really. The only relation is that quite often your impairments on the upstream are caused by your physical tap. So that physical tap could have a loose, there could be a loose connector on there on one of the cables that are connected to that. It could be a corroded connector. It could get water in the tap and could be causing problems. So that is often where the source of the problem is. However, it's not related to digital taps when I'm talking about taps here from that standpoint. So what is a digital tap? When you look at a PNM application, this is one of the visuals that you will see. These are the digital taps. So again, if you think back to that equalizer that I was showing you, the graphic equalizer for sound, think of these little bars, these digital taps, as these sliders up and down, if you will. So basically what you have here are 24 little sampling points in this spectrum. And originally when PNM came out, there were 8 taps, and then they got that a lot more granular with DOCSIS 2.0, I think it was, where now you've got 24 of these taps. And again, these are little slices or samplings of the spectrum that can be individually adjusted at that portion to, again, help that signal or help the cable modem send the inverse signal to the CMTS when the CMTS sees a problem. So you've got these digital taps, and when you're looking at this here, what you've got in this particular one is we're seeing 32 megahertz right here. So there's 2 channels, 32 megahertz and 28 megahertz. And so the 28 megahertz is this light blue color right here. The 32 megahertz is this light kind of purple. And then when you see the darker purple, that's the 2 laid on top of each other. So you're looking at both channels here on the same tap response chart. And normally on your digital taps, you will see tap 8 is always the highest, and it's supposed to be the highest because in a perfect world, if this were in a lab, for example, and there were no impairments, then tap 8, all the energy would be going through that, and then the rest of the taps would be much lower and much flatter, and that's the way you would want it to be. So in this case, we see that that's not what's going on here. And this is from our application, Pre-Equalization Analyzer, and we put a little red threshold line on here to show you, are these taps above the threshold where this is a problem or not? And the reason it goes down here is, right at this point, is taps 9 and 10, especially tap 9, the closer you are to the right of tap 8, the main tap, the closer that means as far as the issue is in the home. So each one of these taps represent 85 feet if it's a 6.4 megahertz channel, or 170 feet if it's 3.2 megahertz channel. So in this case, each one of these is, let's say, 85 feet out, if you want to look at it that way. And that's not from the cable modem. That's talking about your echo cavity kind of distance. So these tend to be, if you see like a shorter distance like this is going to tend to mean that you've got an issue that's in the home or near the home. So when you see taps 9 and 10, that's what you're talking about here. And you see that on the threshold line here, you've got both of these channels are above the threshold on on tap 9. So both of these are indicating on both channels that you've got an in-home problem. Then you've got 10 is also very elevated on 28 megahertz, but it's not. It's well below the threshold on 32 megahertz. So you're seeing these 2 channels are actually acting differently, so they're having different impairments. Then here you can see also again that you've got on 28 megahertz, you've got much higher taps right here. As you start getting out to 11, 12, and further, we're talking about more outside plant issues because your distances are getting longer. So you can see you've got some outside plant issues here. Even this one, 14, is really quite high and close to the threshold, whereas on the 32 megahertz, it's really quite low. Okay, so you can see the difference there. Now on the other side, on the left of the main tap, you've got what would be group delay. So these are really kind of your micro reflections, and this is your group delay, which is similar, but that's what's being looked at on this side of the main tap. So you see that there is actually more group delay when you're looking at the 32 megahertz taps right here in these spectrum slices, these taps, especially here, for example, and then not so much, there is a little bit, but not as much when you're looking at the 28 megahertz. So you can learn a lot just by looking at this tap response. And when you know, in a PNM tool, when you pull up a device, pull up a subscriber device, this is one of the charts that you will see. And you can very easily, quickly see, okay, what's going on here and how far out is my problem. Now, you get a lot of information from this, although the tools, if they're smart enough, will give you a lot more information so that you don't need to know everything. You don't need to be a scientist. But this right here is a very good visual clue of what's going on in these pre-EQ tabs. And again, this is your main tap number 8 that I pointed out right there. Now, we can look at what pre-EQ, turning on pre-equalization in the CMTS actually does. So what we're looking at, this is that same chart we were just looking at with all these elevated taps, and this is the CMTS is seeing before, or what it would be like if pre-EQ was not turned on. So we can look at what the CMTS is telling the cable modems to do and what they're doing, and we can say, what would it look like if they weren't doing that? And that's what we're showing here, okay? But then you can see what's called the post-EQ tap response, and this is what the CMTS is seeing after pre-EQ is turned on. So you can see, again, tap 8, all the way up as you would expect. Here's, again, your threshold line, and you can see that the rest of these taps are much flatter now. So this is the impact of pre-EQ and what that's doing. So again, pre-EQ is something that's just a DOCSIS standard you can turn on in your CMTS. And what we're doing is looking at that data and the pre-EQ algorithms and whatnot, and looking at that and then determining where the problems are and how severe they are by analyzing that data. Something else that you see when you open up an individual modem is you will see the ICFR chart, or in-channel frequency response, and this is looking at the frequency response. If you think about it as kind of like the top of the haystack and what's kind of going on up there, and you can see here this is the same device we were just looking at, and you see we've got our 28 megahertz and our 32 megahertz right here, and you can see the response is really quite different. Again, we saw that the taps were showing that things were quite different on those two channels as well, but in both cases they're not good. You've got, whoops, sorry about that. Probably going to switch. Yep, I am. Let me go back here. So as you would expect, green is good and red is bad. So we've got our kind of our green area, our yellow area, which is more of a warning, and then our alert area up here in red. So both of these are, this one's not quite as bad, this 32 megahertz, but we see it also is in the red here in spots. So this one's really, really bad. So that's what that is showing you. Again, visually, you can see how bad that is. You know, and this, depending on the modem you pull up, it will be anywhere from fairly centered green to some will be not quite as bad as this. But this one, where I got this was, I went into the application and I said, let me look at the worst modem in the plant. And I looked at that worst modem, and that's what this one looks like. What's interesting though, excuse me, what's interesting though, is this worst modem for the subscriber is still responding okay because of pre-EQ being turned on, and we can see that right here. So again, actually before I do that, so this is showing where I was just looking at each individual response for 28 megahertz and 32 megahertz. So again, you can see that they're quite different. I just removed one from the chart, and then I removed the other one from the chart so that you can see what they look like there. But again, this is the first chart I was looking at, and you can see how bad this is. But with pre-EQ turned on, again, this is what we're saying it would look like based on the CMTS information and the cable modem information, what it would look like without pre-EQ turned on. But with pre-EQ turned on, you can see that it looks almost perfect. It's right down the center of the line. So for this subscriber, they're not necessarily experiencing an issue. Everything should look fine for them because pre-EQ is compensating. But as I said before, that doesn't mean that there aren't all kinds of problems out in the plant, including especially right here for this particular device, because this device is really having to work hard to adjust its signal, and it can only work so hard. So what you would really prefer would be to have really good RF spectrum on its own without pre-EQ having to do a lot of compensating. That way your modem's not having to work as hard, and you won't have to worry about, again, this device or something in the near future getting worse with this device, and then suddenly it goes offline. So the idea of proactive network maintenance is to address these things. Even though the subscriber's not having a problem, you're not getting that call like I said, break fix. You're not getting a call that says, hey, my internet's not working well, or my picture looks terrible. You're not getting that call, but you can see here that this customer would be calling you if pre-EQ is not on, and you should really go address that. And the other thing it does is it allows you to do that on your own terms, on your own time frame. So rather than this, again, break, fix, run around and fix stuff when you're getting calls, you can schedule stuff. So you can look and say, okay, well, let's look at some devices in this area where our tech is going to be next week, and let's go ahead and schedule some calls to try to get some of these things fixed. This could be the customer's got a connector in their home that's just loose. I mean, you could even call the customer and say, hey, I think you've got a loose connector on the back of your cable modem. Could you tighten that, and we can see what happens? So there's a lot you can do with this. I wanted to give you an example of a green modem, post and pre and post. So this is actually a device that I just pulled up a green modem, clicked on it, and looked at the ICFR chart, and you can see this is without pre-EQ, and you can see it's a good signal. So you do have these modems, and like I said, you'll have some in the green, you'll have some that are not quite as good as this, and not quite as bad as the other. This is post pre-EQ, and you can see there's not really much difference. This almost looks flatter to me, but really there wasn't much to correct. So you can see the same thing on the taps. This is a green modem, the taps, and again, you've got tap 8 up here in the center, and there's nothing above the thresholds. You can see that you've got tap 10 getting a little bit close, although it's still got this much headroom here. You got tap 11 a little bit close, but not much change here. You know, tap 10 is quite a bit lower after the pre-EQ is enabled, but then you've got everything else looks pretty much the same, not much difference. So that's an example of a green modem in these charts. And you've also, in an application like ours, you will get the table of data for this particular device that you can then look at to get more details. So it's showing you that both channels are red, meaning that there's one or more issues that's saying this is going to be what's going to be a red modem or a red flag on the map. It's showing you, the node and correlation group I'm going to get into in a minute. This is telling me that there's no other modems that are sharing a similar spectral response. So it's not identifying other modems in the area that are being impacted by this. It may be that this channel that's showing an outside plant, and I'll get to this in a minute, of 167 feet, is part of a correlation group, but sometimes when you've got a really bad near-home issue, that can get masked. So, but it shows you the ICFR numbers. It's got your frequencies here. Main tap compression is a calculation of the main tap 8 and then in relation to all the other taps. So as that gets worse, as that number gets higher, then this is going to turn red, and it is red on the 30. Which one is this? This is the 3.2. Oh, yeah, right here, 32 megahertz. So on the 32 megahertz, on the 28 megahertz, that's red. Then you've got your microreflection level, and you can see that's higher, and we noticed that. Microreflections, if you recall from that tap chart on the right, the taps were higher on the 32 megahertz, but the group delay, which was to the left of that main tap, those taps were not quite as high on the 32 megahertz, or excuse me, on the 28 megahertz. So in that case, the 28 megahertz is looking at worse microreflections actually in the red there, and then the group delay, they're both red, but it's not quite as bad on that 28 megahertz. So you've got the table data here, although I think the picture is worth 1,000 words and 1,000 digits in a table, I guess. You've got right here what we call in-home and outside plant distances. So this is looking at the echo cavity of that microreflection, and we're showing that both channels have an in-home issue. This one's a little bit longer, 120 feet versus 70 feet. And we're not showing, again, an outside plant issue on this particular channel, on this 32, but we are on this 28 megahertz. You've got your MER figures right here that you can look at, and these are within, must be within spec, there's nothing red there. Then we've got correctable code word errors and uncorrectable code word errors, and there's nothing showing up for those, so we're not seeing that. We've got our transmit power, these are both in the red, so it's issue there. We've got our receive power, both 0, I don't get that. But. Then we've got our poll time in this particular case. I was looking at this yesterday. So this is the table for that really bad modem we were just looking at. Now, one of the things that you can do with a PNM tool, and this is a screenshot of our Pre-Equalization Analyzer tool, is you can pull up what's called a correlation group. And what the application does is it looks at those in-channel frequency response lines, and basically the data that's getting, and it looks at geographically at the devices that are close to each other, and then it says, you know what, all of these devices seem to have the same in-channel frequency response. And then it plots them on a map for you, and it shows you what those responses look like. So you can look at it and go, yeah, that really does look kind of the same. You've got a few outliers here, but they're still kind of following that same pattern. This purple one, it's still identifying that in there. And then you've got your taps down here. Again, you've got a few little things that are different on these, and that's going to be dependent upon just variations on in-home issues and some other things that are going on related to these. This is a nice tight correlation group, and it's got quite a few modems. So you could see that whatever's causing this problem, if this gets worse and then suddenly gets to the point where, you know, one more thing and one more, you know, the straw that breaks the camel's back kind of thing, you could have all these modems going offline at the same time and suddenly getting lots of calls and trying to figure out where that is. And that's where proactive maintenance comes in, is you can look at this correlation group if you have something like this and you go, okay, let's try to figure out where this is and fix it before we have an issue that's going to take everybody down. And then we're scrambling trying to fix that rather than scheduling that and taking our time. So, and you'll notice here, you've got this yellow modem in the midst of all these blue modems, and sometimes you'll see this. You might see a yellow modem here, a red modem there, that kind of thing, around, you know, surrounded by some blue modems. And usually what that means is that this particular device, maybe it's got such a bad in-home problem, you know, some other issue that its in-channel frequency response is different enough that the application just says, well, I can't really correlate this one because it's different enough that I can't do that. But visually, you can look at it and go, okay, well, this has got to be part of this correlation group because these, you know, this is way over here. And basically what you're looking at here is all of these devices are going through a common upstream path that has an issue on it, right? So this one should be having the same issue. So you can always, in the application, click on that, open its ICFR chart and its taps, and you can compare it with the other ones and go, oh yeah, it's close enough. It's definitely being impacted. So I wanted to talk about this first because sometimes, you know, the question comes up, okay, well, you're showing me this, and in addition to showing you this, again, you'll have if there's a correlation group like this, you will have an outside plant distance like I was just showing you, so like that 167 feet, 300 feet, whatever. So the question comes up, okay, what do I do with that? I've got a distance and I can see it on the map, but what is that distance referring to? Is that from a modem to what? To my next device, or what is that? So here, this will help explain, I think, as we go through this. So, you know, first off, on a cable plant, it's supposed to be 75 ohms, right? So that means, as far as impedance, so that means from your cable modem all the way to your CMTS, you know, in an ideal world, 75 ohms. But there are things that, you know, these impairments like microreflection or whatnot that will get that out of whack, and then you've got an impedance mismatch, and the worse that gets, then the worse the signal is, right? So, and where can that happen? That can happen really anywhere along the line. So it can be connectors, terminators, it can be actives, passives, it can be the cable itself, gets a kink in it, gets a crack in it, that kind of thing. So any of these things can cause an impedance mismatch, and that's what we're looking for, is what is causing that problem. And usually what we're identifying here is a microreflection. So you've got, here's just an example, you've got your cable modem, and it needs to communicate back upstream to the CMTS, and as it's doing that, maybe it passes through a active like an amplifier, and it hits a passive device of some kind. Maybe there's a bad connector on there, corroded connector or something like that. So that creates a microreflection, and most of that signal gets through, but part of it bounces back, that reflects back, hits that active, which is not supposed to let it through this direction, and then that reflection is going to reflect right on back again toward the CMTS. It's going to hit that same impairment and get reflected all the way back again, back to here, and again, can't go through there, so it's going to reflect back. So you got this microreflection, and basically the distance between these two things is what your echo cavity is. So that's the echo cavity, and that is the distance that we're looking at. So we're looking at the length of that echo cavity is what you're given when you see an outside plant figure in the PNM tool, specifically in our PNM tool. So we look back at what I was just showing you on this map here. Again, here's my correlation group. All of these blue flags are identified as a correlation. We got this yellow one that's probably, and almost definitely in the correlation group as well. If I clicked on that, if I could, this is a screenshot, but if I could click on that, I would see, I'm sure, a very similar in-channel frequency response right there. I could click on this one to see what it looks like, and more than likely, let's say that one does not look like this. That one, it's yellow, so it's not a great modem. It's somewhere in the yellow, but maybe it's got a totally different squiggly line up there for the ICFR. So let's say that's the case. So what I'm looking for when I'm looking at this map is the first good modem and then the last bad modem. Or really, I guess it's the first bad modem and the last good modem, if you want to look at it that way. And then somewhere between those two things, I know I have a problem, right? So it's somewhere between, let's say this is my first bad modem, my last good modem. Somewhere in between here, I've got a problem. It could be, like I say, it could be a crack in a cable where some water's gotten in. It could be there's a active or a passive here with a bad connector. Could be a, like I was talking about, tap or something that's got a problem in it. But everything in this case would be going through, all of these devices would be going through the same path. So for all of these devices, they have the same echo cavity to deal with, right? Other than little other things that are going on with those devices, like I say, maybe an in-home problem, but they're all having to pass through this particular path here. So they're all going to have that same outside plant echo cavity. So that's the distance you're looking for. So you're going to look at these two areas right here. Again, your bad modem and then your first good modem, last good modem. I'm trying to remember which direction that goes. And then once you do that, you know where to look, and you've got your distance. Now, something else you can do, depending on the application, in ours you can do this. There's a little layers icon up here, and if you've got digital strand maps, you can load them in the application. You know, as long as they're digital and everything's geocoded, you can load that in the application. Then you'll have this same map here, but we overlay on top of that your strand maps. So we can show you your poles, your cable, your actives, your passives. They can all appear on the map. And then you can look at it and you go, okay, well, let's see. Let's say your outside plant distance that we're showing you is 334 feet. You can then look and say, wow, I've got a span of cable between this active and passive right here that's about that distance. And you can go look and check the connectors and whatever on that. Or you might have a span of aerial cable, and you go, you know, I think it's somewhere in there, and you can inspect that in that particular area and see if you can find out where the problem is. So it really does help you kind of narrow down where the issue is on something like this when you've got a common impairment like this. So that's how you would measure that. That's how that works. Now, something else that is available in some applications, this is available in ours, would be downstream spectrum. We look at full band capture. So any cable modem that supports full band capture, which is really, I think, anything you can buy today and for the last several years, would be full band capture capable. And that basically has a spectrum analyzer within the cable modem, and it can report that information and then show you a spectrum chart, just like you would see if you had a meter right there at the cable modem. So you can pull up any device and look at the downstream spectrum if it supports that. So it's a way to kind of see if there's a downstream spectrum going at the same time. And something we just added to the application is a downstream spectrum correlation. So we look at devices that are experiencing the same downstream spectrum issue, and we correlate those. So in this case, all of these devices that are blue here are showing that there's a suck out right there. And you can see we've kind of got the spectrum stacked on top of each other. The amplitude is a little bit different, which is normal, but we've got a suck out that's affecting all of them in the same spot. So we know there's something that's affecting all of these devices. This is a new feature for us. And you can see, again, here we've got some interspersed devices that are not showing that. Again, because of various things, there might be some slight differences that, you know, one of them might have some other issue going on, like an adjacency or something like that, where we're saying we're refining the correlation groups on this, but we might say, okay, well, we're not sure enough on this one, so we don't include it in the correlation group. But the nice thing is you can click any of these map pins, and you can, once you do that, you can see, okay, what does it look like on this one? What does it look like on that one? And as you do that, this little pop-up is going to show you, yeah, okay, this device has got a suck out in the same spot. So I clicked, I think I clicked a yellow one that was not in the correlation group, and I say, okay, well, that suck out sure looks like it's in the same spot, so that really should be correlated. But why wasn't it in the correlation? Well, it looks like there's some other things going on here. There's some rippling going on here, and a lot of maybe some more significant tilt on some of these. So these are being correlated where this one is not. The signal looks a little flatter on the rest of this, okay? So it didn't correlate it, but it's very easy for me. I can just click, 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 very easy for me. It's like a virtual sweep. I mean, imagine that. You don't have to go to each house and do this. You can just click right on the map. So I could easily click and see, and I can go, oh yeah, well that's definitely being affected by that same suck out. The rest of the signal looks a little better, but I think that's why this one was not included in this particular correlation group. So that's something else. Again, proactively, you can look at this and you can go, okay, well, I haven't had any calls from these customers, but I see the suck out, and that can be causing some issues for them. So I'm going to go ahead and see if I can address that. And, you do the same thing. You can just click and try to find where the signal gets better. You know, it might be this one, it might be this one. You're just going to find where the suck out goes away, and then it gives you an opportunity to look about where that cause might be. And something else we've added as well with DOCSIS 3.1, we've got an RX-MER correlation group, so this can show you on your OFDM channel if you've got any issues on the subcarriers there that are being shared. This is also a new feature, so in this case I've got the RX-MER charts overlaid on top of each other for all of these devices, and you can see we've got MAC addresses here. You can click and open those, and I can click, same thing here, I believe it's in the application. I had to get a screenshot from somebody. I didn't have a DOCSIS 3.1 modem to look at the time, so I think it's the same thing where if I were to click on this one, for example, then I would see the little pop-up chart right here of the RX-MER response, be able to compare those just to, again, find my first good modem, last bad modem, so I can then compare those and find out where the dividing line is from, so that helps me find out where this issue is. So this again is something that we added for DOCSIS 3.1. So again, proactively you can look at this and then try to figure out what's going on. And then a couple other things I just wanted to mention that are part of, I think, what cable operators are able to do today with software and using some of these new kinds of PNM tools that are in DOCSIS. And by the way, DOCSIS 3.1, I think it is, yeah, 3.1 is actually incorporated some PNM things, whereas before it was not necessarily incorporated in the DOCSIS standards. In 3.1 it was. So cable manufacturers had to include these things like full band capture in their devices. Something else that we look at that again can really help you proactively, because what we're looking at here is we're targeting multiple devices, but sometimes it's better to start with, let me find out my worst individual devices, because those, you know, again, if you've got lots of bad individual devices, they can be letting a lot of ingress into the plant, and they can also be impacting what the signals look like, and then it's hard to figure out your correlation groups from there. So here I'm looking at a feature that we call an intermittent modem report. So it gives us a report of devices that are experiencing the same, devices that are being correlated, this different kind of correlation between their, what's called the MTR or main tap ratio. That's a kind of a pre-EQ analysis that we do of those digital taps, and then the cable modem transmit power. So we are looking at when the cable modem transmit power changes in relation to those digital taps. And what that's telling us is that at particular times this modem seems to be fine and flat. There's no change in those two things, but then there are times when the digital taps, the modem has to adjust its pre-EQ taps. At the same time, it's adjusting its cable modem transmit power. So we go, you know what, this device seems to be reacting to ingress, to some noise that's coming in very nearby that device. So it tells us this particular device probably has an in-home or near-home issue, something that's going on that's letting noise in at specific times, not all of the time. And it's really nice to know this, because intermittent issues can drive you crazy, right? So you're out there, you know, customer calls, hey, I'm having a problem. By the time you get out there, it's gone. It's not happening, because maybe that noise source is not happening right at that particular time, or maybe whatever it was, that maybe that, I don't know, somebody rolled a chair over a cable or something that caused something to, you know, get loose, and then, you know, it gets better, you know, it's like a loose connector, that kind of thing. So we see here, right at this point, it's very easy visually to see, and then we also mark it off with a green line that this particular device is responding. Here we've got our main tap ratio. This is the pre-EQ values changing at the same time that the cable modem is transmit power is going up. And we can look back in time. You can click back here and look at another polling period, and I can see the same thing happen. And quite often, we got to see it for a couple of polling periods in order to mark it with the green line, but quite often you can see, not so much on this one, but you can see, even though it's not showing you can see that these lines are moving a little bit kind of in the same direction, not so much on this chart, but that can help you as well. And then finally, I wanted to talk a little bit about what we have available on the upstream side as far as really what is a upstream analyzer, all from the CMTS. So you don't need to buy any equipment. You don't need any kind of expensive return path monitoring equipment in order to be able to see what your upstream looks like, see your noise floor, because this CMTS will support this now, where you can then pull or basically view the upstream spectrum as it's passing through the CMTS. So this is just a screenshot that I took here of a particular plant where I've got I'm looking at this yellow channel. So when you're looking at a channel, it's the yellow one, and really what I'm looking for is the noise floor under that channel, and specifically you can actually look at the ingress under the channel. So it normally would take very expensive return path spectrum equipment to do that, something that can sample very quickly. But in this case, with this tool, we know when the CMTS knows when it's communicating with a modem or modems, and we can actually plot when it's not and look at what the noise looks like underneath that. This one here is the adjacent channel, so we're not really looking at that, and that one is showing noise. It looks like noise over here, but it's really just the haystack of this adjacent channel. So I'm looking right here, and this is what's of interest to me. I've got ingress under the carrier turned on. I could also turn on max hold and min hold if I wanted to, but the only things I had turned on were live and ingress line to see what that looked like. So your black line is the live line, and your red line is the ingress line under the carrier right here. And I can see that I've got quite a bit of ingress. I even can see that I've got it under this channel. If I were to click this gray box over here, then these two would swap, and I would have my here, I would be looking here, and I would not see the haystack over here. I'd be seeing the ingress under the carrier over here. And when I looked at it, it was actually not bad. It was actually fairly low. It actually started ticking up right about here under this channel. So this gives you the ability to do upstream spectrum analysis without having to have a whole bunch of cables plugged in, and you can see any channel that you want at any time. You don't have to move cables around. You don't have to have any expensive equipment to do this. You don't need an expensive upstream or spectrum analyzer. If you've got a CMTS, you can do this. So that's something else that, again, I see this as proactive, because you can see, oh, I've got an issue right here that I need to go look at. And then, like I say, you can kind of go back to this tool. If you start targeting these homes, then you will have a favorable impact right here, right? Because each one of these homes that are letting noise into the upstream, if somebody's got a bad in-home, like a loose connector or something outside, let's say, that's opened up, maybe you've got a unterminated connection or something, a house that's opened up and it's letting in noise, I mean, that's flowing up the upstream to the CMTS, and that's going to impact every single customer. So that's going to be the kind of thing that's going to be showing up right here, that you've got this ingress. So as you target those individual homes, and this tool will let you find those, then you can then improve this. You will start to see, as you make those targeted improvements, just start going down the list and finding your worst offenders as far as ingress goes, you will start to see this flatten out right here. So you can make a tremendous difference there. I think that was it. Yeah. No, I was going to show you that this particular tool also has an upstream monitor. So we can click on the monitor tab up here, and we can go back in time and see what it's looked like over time. So you can just hit the play button, and we're taking a snapshot every hour at what the spectrum looked like. So you can see it. What did it look like? Okay, it looks really bad today. What did it look like a week ago? When did this start? Is there a particular time when it started? So we've got upstream monitor there, and we're looking at here. We're looking at max, min, and ingress under the line, as I was showing that. And you put, you see, you can put in your start date and your end date, or you can just play or click the buttons to see that. So, all right. So that is the basics of PNM. So hopefully this was helpful here. Let me see. I think I got a question. Does that work with any CMTS 3.0 or 3.1? I can't say any. It works with, there are one or two, I don't want to say who they are because I don't want to be wrong and then be wrong about that. But there are one or two CMTS models that I'm aware of. It might even be just one that I'm aware of that doesn't work. If it's let's say it's a DOCSIS compliant, maybe an older CMTS. I think the new ones are supposed to support this. But I think, for say 3.1, 3.0, I don't want to say who it is, but I think there might be one that we haven't been able to make this work with. And then some of the features may not work on some CMTS. I think there might be a CMTS, for example, where maybe the ingress under the carrier doesn't work. And on some CMTS where we would like to not show you the haystack on the channel that we're looking at. On some, I think there's one CMTS in particular where it just is going to put the haystack up here. So it's still useful. You can basically, what you can see, you can watch the ingress under the carrier, and occasionally you'll see the haystack pop up here, but you can still kind of tell what's going on under the channel there. So hopefully that answers your question. And if you would like to know about your particular, this from KD, if you'd like to know your particular CMTS, feel free to you can type it in here as to what it is, and I can let you know on the comments if it works, or just send us an email. If you've got any questions like that, you can email info@zquorum.com, and I will get that, and I'll get you an answer. And if you'd like to know more about this particular application, you can email us about that. You can give us a call. Go to zquorum.com, look for DOCSIS PNM, and you'll, in the menu there under Solutions, and you will find out a lot of information about the tool that we have here. And we've got other resources on our website and on our YouTube channel that will help you if you are a user of this tool and you'd like to know more. I've got some videos specifically about that intermittent modem report. I've got a video where I showed Tim Smith and I went through and we showed how we found where an issue was in a cable plant, a correlation group that was impacting multiple customers. I'll go ahead and post a few of those here. The other thing that I'll post on the comments as well after this is, again, a couple of weeks ago, I did a 3-week series on this application because we got version 5, which you're seeing here is version 5. We've got that coming out now that we're starting to upgrade customers to, and I went through some of the new features, so you can get a real good idea of me going through the application live and showing some of those features, so I'll put that on as well. But thanks for joining me. Hopefully this was helpful. Again, PNM is a very powerful tool. It's kind of an art and a science, but there's a lot of science behind it that kind of points you in the right direction. From there, all you have to do is know a little bit about how to use it, and you can really make a tremendous difference in your plant. You can get your cable plant a lot cleaner. Again, you can reduce operational costs, reduce truck rolls, a lot more efficient in how you tackle these problems, and I think maybe most importantly is your customers will be a lot happier with you, and that's really important these days, is to make sure that you're providing a good experience for the customer. And as your plant gets cleaner, and if you can resolve problems sooner or before they even happen, that's fantastic. So thanks for joining me. I'll be back next week for Tech Tuesday at 3 o'clock, every Tuesday, 3 o'clock right here. So I will see you then. Bye-bye.